Have you ever noticed how some things in life seem to grow or shrink in a wonderfully predictable way? Think about a snowball rolling downhill or a spreading rumor. There is a simple mathematical pattern that explains many such phenomena. What defines a geometric number sequence is a consistent multiplicative relationship between its terms. Put simply, each number in the sequence, after the very first one, is found by multiplying the previous number by a constant, non-zero value. We call this special constant the common ratio. This common ratio is the absolute heart of a geometric sequence. For example, in the sequence 2, 4, 8, 16, the common ratio is 2 because you multiply each number by 2 to get the next. In another sequence like 90, 30, 10, and then 3.33 repeating, the common ratio is 1/3. It is important that this ratio is always non-zero. If the common ratio were 0, every term after the first would simply become 0, which would not be a very interesting pattern. This constant multiplication is what sets geometric sequences apart from arithmetic sequences, where you add or subtract a fixed amount instead. The power of a geometric sequence lies in this repeated multiplication, leading to rapid growth or decay. To actually identify a geometric sequence, you just need to check if that common ratio exists. Pick any term in the sequence, and then divide it by the term that came just before it. If you get the same answer every single time you do this for several pairs of consecutive numbers, then congratulations, you have found your common ratio and confirmed it is a geometric sequence. Once you know the common ratio, finding the next numbers is straightforward. Just keep multiplying. This concept extends far beyond simple number lists. Geometric sequences describe many real-world phenomena. Think about compound interest in banking, where your money grows by a consistent percentage each period. Or consider population growth in ideal conditions, or even radioactive decay, which is a process of exponential decline. These are all prime examples of geometric progression at work. Understanding them helps us model and predict changes in a wide array of systems, from financial planning to scientific research. Recognizing a geometric number sequence by its constant common ratio empowers you to understand and forecast patterns of consistent growth or decay. It is a fundamental tool for making sense of how many things in our world evolve, offering a clear lens through which to view everything from savings accounts to environmental changes, making previously complex changes predictable and understandable.
If you love exploring numbers, like, subscribe, and keep counting with us.